All right, so one of you asked me about this question number 4 on our IB log problems, and I am going to do partially. I'm going to give hints. I'm not going to do it all directly, but I'm going to describe some ways that you might approach this problem. And so what we're looking at here is we're looking at a exponential function, and we are told something about the x and the y value. And so if you know the x and the y value, you can plug them in. That goes for x. This goes for y. And I want you to think about, how do we get rid of powers? We don't know what the base is. That's what the question asks us. The question says, prove that the base has to be 8. Okay, so if you don't know the base, how do you solve for it? Think about a situation like maybe if we had x to the third equals 27. How would we solve that? Or if we had x to the 1/2 is equal to 3, how would we solve that situation? Okay, and please also remember we have this idea that if you go x raised to 1 power and you raise that to another power, you can multiply the two powers. So that might give you a hint for how you can solve when you don't know the base and you want to get rid of the power. Think about, can you raise it to another power on both sides? That would get it down to just be the base by itself. Okay. Part B says write down an expression for f inverse of x. That doesn't mean actually raising it to the negative 1 power. I know it looks like raising it to the negative 1 power. That just means the inverse. Okay. And so we're starting with an exponential function, f of x equals a to the x, and we're asked to write an inverse function. Think about what inverse means. Inverse of an exponential. What kind of thing do we use for inverse of an exponential? And how can we switch around the original equation to be its inverse? And then we're asked to find the value of f inverse of square root of 32. So you have your inverse expression, and you're plugging in the square root of 32 into it. Okay? Then next one asks us to consider the arithmetic sequence. And what's sort of weird about this question here is it doesn't even seem to be super related to the other one. So what I'll show you is that when you have an arithmetic sequence, you know that the first term plus the common difference has to be the second term. You know that the second term plus the same common difference has to be the third term, etc., etc. And so if you solve for the common difference, you know that the common difference is log base 8 of p minus log base 8 of 27. And think about how you can use a log property. You know that if there's subtraction between logarithms, you can rewrite that as a single logarithm. Okay, and that's going to be a very crucial fact, is that you can take two logarithms, subtract it, and make it into a single logarithm. And then the last hint I'll give you on this problem is that if I have log base anything, let's go base a of x equals log base a of y, then I can cancel out the logs from both sides, and x is equal to y. In other words, if both sides have the same log base, then you can set their inputs equal to each other. So solve for d, use your log rule to make this into a single log, and then cancel out. Then you should be able to show that these are geometric terms, and based on that information, figure out p and q. And I will give you one last hint that the first part does relate to the second part, even though it doesn't seem like it on the surface. All right, please let me know if you have any questions. Thanks for watching.